Blood sugar regulation is a constant biological tug-of-war happening inside your body right now. At the center of this intricate balancing act are two powerful hormones, insulin and glucagon. These molecular rivals engage in a continuous duel that keeps your energy levels stable and your cells functioning properly. Both insulin and glucagon are produced by the pancreas, specifically in regions called the islets of Langerhans. But despite their shared origin, these hormones have completely opposite functions. Think of them as the yin and yang of blood glucose regulation, each counteracting the other's effects to maintain perfect balance. Insulin is produced by beta cells in the pancreas and acts as the body's primary signal for lowering blood glucose. When you eat a meal, especially one containing carbohydrates, your blood glucose levels rise. This triggers the release of insulin into the bloodstream. Insulin then binds to receptors on cell surfaces throughout your body, signaling them to absorb glucose from the blood. It's like a key that unlocks the door, allowing glucose to enter cells where it can be used for energy or stored for later use. In muscle and fat cells, insulin promotes the uptake and storage of glucose. In the liver, it suppresses glucose production and encourages the conversion of glucose into glycogen, a storage form of carbohydrate. Insulin essentially tells your body, energy is abundant, let's store it away. On the opposing side of this metabolic battlefield stands glucagon, produced by alpha cells in the pancreas. Glucagon's mission is precisely the opposite of insulin's. When blood glucose levels fall too low, such as during fasting or exercise, glucagon is released. Its primary target is the liver, where it stimulates the breakdown of stored glycogen into glucose, a process called glycogenolysis. Glucagon also promotes gluconeogenesis, the creation of new glucose molecules from non-carbohydrate sources. The message glucagon sends to your body is clear. Energy supplies are running low. Let's release more fuel into the bloodstream. This raises blood glucose levels, ensuring your brain and other vital organs have the energy they need to function properly, even when you haven't eaten for hours. The beauty of this system lies in its precision. In a healthy body, insulin and glucagon work in perfect opposition, like two sides of a scale. When one increases, the other decreases. After a meal, insulin levels rise while glucagon levels fall. During fasting, the opposite occurs. This delicate balance keeps blood glucose within a narrow, optimal range, typically between 70 and 100 milligrams per deciliter. This hormonal balancing act happens automatically and continuously throughout the day. As you go about your activities, these hormones respond to your changing energy needs, ensuring that glucose is available when needed and stored when abundant. When this balance is disrupted, metabolic disorders can develop. In type 1 diabetes, the immune system destroys insulin-producing beta cells, resulting in insufficient insulin production. Without insulin's glucose-lowering effects, blood sugar remains chronically elevated. In type 2 diabetes, cells become resistant to insulin signals, again resulting in elevated blood glucose despite often normal or even increased insulin production. Understanding the insulin-glucagon relationship helps explain why managing diabetes often requires more than just insulin replacement. The entire regulatory system must be considered, as these hormones don't work in isolation but as part of an intricate network of metabolic signals. The duel between insulin and glucagon represents one of the most elegant examples of biological balance in the human body. These opposing hormones, through their continuous push and pull, maintain the energy homeostasis essential for life. Their rivalry isn't a battle for dominance, but rather a sophisticated dance that keeps our metabolism in perfect harmony.